Hello, Jessica. I would be more than happy to go over this stuff with you. Let's check out the first one here. We're going to multiply. So what we're going to do is factor everything completely first, okay? This is a trinomial. I'm going to factor that out. Now, x and x for us, this first one. Now we're looking for two numbers that multiply to equal positive 20 but add to give us negative 9. That's negative 4 and negative 5. Downstairs, we'll factor this trinomial as well. I'm going to go x and x. Now that's going to be negative 4 and positive 3. Positive 3. I'm going to write this over here. Oh, what happened there? Over here, difference of squares, so x plus 3, x minus 3 over here. And then down here, difference of squares again, x plus 5, x minus 25. Or sorry, minus 5. So I hope that's okay. Remember, differences of squares, when we're subtracting two perfect squares, we basically take the square root of the left term, goes in each bracket, square root of the right term, goes in the right of each bracket, and then we make one positive and one negative. So that's the play here. And over here, this is back in P6, factoring trinomials. I hope you're okay with that, but if not, let me know. I can definitely talk to you a little bit more about that. After that, I'm going to get the old canceling color out, and we're going to cancel whatever we can. So I have an x minus 4 and an x minus 4. I got a plus 3 and a plus 3. I got a minus 5 and a minus 5. And that's pretty well it. Remember, because everything is factored completely right now, everything is being multiplied all together, we can cancel or divide. Same thing. So, you know, I have x minus 5 over here. I can definitely get rid of this guy over here. If it's anywhere in the top, anywhere in the bottom, they can be canceled. Let's talk about what we have left. Our final answer, simplified. Pardon me. X minus 3 over x plus 5. Okay? So there it is. The exclusions, by the way, remember we have to take a look back throughout the whole problem. Okay, so x cannot equal, here it can't be 4, because 4 minus 4 would be 0. It can't equal negative 3 right here on this x. Okay, can't equal negative 5, and it can't equal 5 as well from this guy here. Okay, because if at any point we get a 0 in the denominator, because everything is all factored completely, they're all multiplying, everything will go to 0, and that's not good. So there's the first one. I hope that helps. Let's skip down now and we'll talk about this complex rational expression. Now here what we're going to do, I'm just going to rewrite this big division sign as a divide sign. So literally I would rewrite this as 7 over x plus h quantity squared minus 7 over x squared divided by h. Okay, so I'm just taking care of all that. But basically the understanding is that we're going to work on this stuff first. Let's factor this out completely, or, you know, well, it is kind of factored already. It's basically like, let me write that a different way. Instead of x plus h quantity squared, let's write it as x plus h, right? The same thing twice. So our LCD here is going to be x plus h times x plus h times x squared. That's literally our LCD. So we're multiplying all this stuff together here. So don't think about, you know, oh, well, I have an x here and an x here. This is different. This has to be added first. It's in brackets. It's not the same. So our LCD, and I'll write this divide by h again. We're not going to go there yet. Our LCD, x squared, x plus h, x plus h. I'll write the same thing over here. Okay, so the only difference here, I have an x plus h and an x plus h here. I have a 7 already. So the only difference is I'm multiplying down below by x squared, so I'm going to do the same up top. This is now an equivalent fraction to this. Down here, I already have my x squared, so up top I'm going to multiply this by x plus h, x plus h. Again now, this is an equivalent fraction to that. Okay? This is going to be a monstrosity, this one. Woo! Okay. Let's combine some like terms here, but before we do that, I have to multiply. And when we have two binomials, we have to FOIL them out. So up top, I'm just going to rewrite everything anyway. I have my 7x squared minus, and what's going to happen here, I'm going to do my first, which is x squared plus 2xh plus h squared. Okay? And all of that is over my common denominator, x squared, x plus h, x plus h. Okay, so I just FOILed that out. First outside, inside, last. You're going to get two xh terms, so that's why I combined them there. I hope that's okay. Now I need more room. This one's getting out of hand, big time. Okay, let's distribute this negative 1. So I have 7x squared minus x squared minus 2xh minus h squared. Okay, and all of that again is divided over x squared, x plus h, x plus h. Okay, and remember we're still dividing by h over here, somewhere over there. We'll deal with that later. Let's take a look at some like termage. We have some x squared terms, that's cool. We'll do that up, so 7x squared minus x squared is 6x squared minus 2xh minus h squared all over x squared, x plus h, x plus h. All still divided by h. Now, can we do something here? Can we eliminate some more of this stuff? Alright, so basically, like, is there a way, let me get color out here. This is a trinomial. Can we factor this trinomial out a little bit more? Can we reduce something? Can we pull out something here? Let's take a look and see what we can do. So at this point, I literally have no idea what the answer is, but we're just going to try to factor this, okay? So, 6 gives us a possibility of 1 and 6 and 2 and 3. So let's go 2x and 3x. Okay, and with negative h squared, that's just like basically h times h. Okay, so if we kind of combine this out, there's really no way, I don't think, that we can combine such that we're going to get a negative 2xh in the middle and a negative h squared here, right? Like that would just have to be times h. It's not going to happen. So we can't really factor that way. This trinomial is not factorable. And not all of them are, such as life. But is there a common term here? What can we pull out? Well, nothing really there either. So I guess we'll stop there for now. And I'll change this. Instead of dividing by h, we'll multiply it by 1 over h. Is there something that we can do now to get rid of that? Let me just double check my work here, guys, because I missed a step. I definitely did. That's not canceling the way it should. That's a bit of a mess. Sorry, I'm just making some room because I know I'm going to need it. Okay, let's see what I missed. I factored that, but that's a negative 7 out there. I missed that negative 7. So let me redistribute now, we'll see what we get. That's going to be 7x squared minus 7x squared, there we go, minus 14xh minus 7h squared. Okay? All over blah blah blah. This is going to cancel now, so our x squareds are gone. So I'm left with negative 14xh minus 7h squared all over x squared, x plus h times 1 over h. I'll flip that now, we'll do that. Okay? There we go, that looks a little better. So, there's a common term here, there's an h term that I can pull this out. So let's factor this. This is really just a binomial, even though it's ugly, and we'll see what we have left over. So the GCF here is going to be, we can think about it as a negative 7. Okay, now if I divide that out, that's going to be, a negative 7h. If I divide that out, that's going to be 2x minus, plus h. Okay, so what I'm doing there, I'm just factoring out and dividing all this by negative 7h. So this negative 7h comes out. Negative 14 divided by negative 7 is plus 2. The h's go away. We have an x left over. Over here this equals just 1. Any two negatives divided equals 1. This h cancels with one of these h's, but we still have one left, and it's still multiplied by 1 over h. Okay? Now that everything's factored, we can eliminate that h. So that's gone. What we have left is negative 7 times 2x plus h. That is all. We're effectively done. That 1 is gone. That h is gone. Or you could now distribute. Maybe I got a little greedy there. We could call that negative 14x minus 7h. Okay, so there it is, kind of simplified. I went too far. You don't have to pull out that 7, guys, because there's no way I can cancel that. So there it is. That's a bit of a monster. My goodness. So basically the play, when we're doing this, forget about that dividing and get that common denominator. And the common denominator usually is just basically slapping everything together. I had to add the x squared here, so slap that on up top. I had to add this x plus h, not add, but multiply. X plus h, so do the same here. Then we're doing order of operations. You have to FOIL it first. Don't miss the 7 like I did. Then you're going to distribute and combine like terms. Basically, then look for your common term, which is an h, and that will cancel with that h down here. And just kind of sum up and simplify the rest. Don't put brackets. So Jessica, I hope that helps. If not, let me know.